Hello everyone and welcome to lecture 17. If you recall, for the past couple of sessions we have been discussing the notion of marginal analysis, which is the idea of taking small steps. And the first example that we looked at was a firm which was producing CDs, and we were given an inverse demand function, and the question that we were interested in asking was, what is the number of CDs the firm should produce, or what is the output that the firm should produce in order to maximize its profit. Now we solved that example in three different ways, right? One was we took the case, we started with a guess, right? And as is with any guess, there is nothing right or wrong about this. So we started with a guess of Q equal to 1000. So suppose the firm is currently producing 1000 units, and then we asked, is this the best that the firm can do? So to answer that, what we said was, suppose the firm takes an extra step, right? In this case, the one extra step for the firm is increasing its output from Q equal to 1000 to Q equal to 1001. And then we asked, what is the revenue of the firm, what is the cost of the firm, and what is the profit that it incurs? And we found that producing that one extra unit increases the profit of the firm, that is, it moves to a higher point on its profit hill. Now if you recall, we did all of this analysis in the form of this example, where we introduced the terms of marginal revenue, marginal cost, and marginal profit. And we said, as long as the marginal revenue is greater than the marginal cost, producing one more unit is going to increase the profit of the firm. If the marginal revenue is less than the marginal cost, the firm ought to decrease its output. And profit is maximized when marginal revenue is exactly equal to marginal cost, right? Then we said that suppose I want to find out exactly what is the Q star, and that's where the tools of calculus was very handy. We said, by either setting the marginal revenue to equal the marginal cost, or by setting the marginal profit to equal 0, we can get the Q star. And finally, we put all of this together by drawing the graphs, and we saw that the graphical approach complements the previous two approaches. Okay. Now let's move ahead and look at example 2. Now if you look at example 2 here, right, what I have is that now I have a firm which is producing two goods. Let's call these goods as good A and good B, right? And because there are two goods, I need two inverse demand functions, right? And notice the two inverse demand functions are given by PA as a function of QA and QB, and PB as a function of QA and QB. So the inverse demand function of good A is given by this expression. The inverse demand function of good B is given by the following expression. Now, if I look at the nature in which the PA and PB depend on QA and QB, right, notice that an increase in QA, if the QA were to increase, keeping QB constant, the price must fall, right. So if I increase QA, PA will fall, right, keeping QB the same. Well, that is coming straight from the idea that if the quantity demanded of good A has to increase, if I want consumers to buy more of good A, the price per unit of good A must decrease. But interestingly notice that when QA increases, keeping QB at the same level, the PB must actually fall to maintain the equality, right. So that's telling us that good A and good B here are substitutes. Okay, so A and B here are substitutes, are substitute goods. Alternatively, I could invert the inverse demand functions, write them as demand functions, and you will notice that an increase in the price of PA will increase the demand for good B and vice versa, right. I will ask you to check that, right. So just rewrite the inverse demand functions as demand functions, QA as a function of PA and PB, QB as a function of PA and PB, and you will find that when the price of good A increases, the demand for good B will increase. When the price of good B increases, the demand for good A will increase, consistent with the idea that good A and good B are substitutes. Now the question that we are interested in solving is, what are QA and QB in order to maximize profit? So what output should the firm choose? Now notice, unlike the previous example where I started with Q equal to 1000, where there was only one good, now if I want to do a marginal analysis of the same form, I will need to actually have two values that I begin with, right. I will need to start with a value for QA and I will need to start with a value of QB. So let us start with the following values. So let us say, so we will use calculus, right, but let us first do it the way we solved the previous example. So I want to start with values of QA equal to, let us say 1000, right, QA equal to 1000 and QB equals 5100. I could have taken 5000 as well, right. So don't read too much into these numbers. You could choose different combinations of QA and QB and repeat this exercise. So I start with QA equal to 1000 and QB equal to 5100, and the question that we are asking is, so how can we use marginal analysis? How can we use marginal analysis, right, to see in which direction the firm should change its output. This is what we are interested in, right. So this will involve a little bit of an arithmetical exercise. So my suggestion is that we move to an Excel sheet and do this arithmetical exercise, right. So let us use this sheet, okay. So let us start with value of QA equals 1000, which is what I had earlier, and let us start with the value of QB, which is equal to 5100, right. Let me write down the two inverse demand functions first. So I am going to call this to be PA, which is equal to, so if I have the inverse demand functions, it will be 90. So given that the firm is producing 1000 units of good A and 5100 units of good B, can we find out what is the per unit price of good A and what is the per unit price of good B? So based on the inverse demand function, that is 90 minus, I can write this as 90 minus QA divided by 100 minus QB divided by 300. This is the per unit price of good A. So 63 rupees per unit is the per unit price of good A. Similarly, if I identify the per unit price of good B, I will use the inverse demand function for good B. So that is going to be 120 minus QA divided by 150 minus QB divided by 300 or QB divided by 100, sorry, right, QB divided by 100. So this is the per unit price of good B. Now that I have the per unit price of good A and good B, I can find out how much the firm earns as revenue exclusively from the product line A. So think of two different products that the firm is producing, right. So this could be the regular Coca-Cola and the Diet Coca-Cola, right, or some other flavor. So that is going to be the so recall, revenue is always the per unit price times the quantity. So it is the per unit price of good A times the quantity of good A that I am selling. So this is in rupees term. Similarly, the total revenue from good B is the per unit price of good B times the number of units of good B that I am selling, which is 317,900, right. So this is the per unit price. So per unit price, which is D7, times the per unit quantity, which is D3. Now the total revenue that the firm earns is the revenue from good A and the revenue from good B. So the TR is going to be essentially the sum of the revenue from good A and the revenue from good B, right. The advantage of doing this in this Excel sheet is that now if you do not like this guess, and let us say you started with a per unit price of the guess was 1500 units for good A and you keep good B at the same, the numbers will change and accordingly you will get the total revenue, right. So, let me go back to the previous number of 1000 as the quantity. So, this is the initial setting where I started with a guess the firm is producing 1000 units of good A, 5100 units of good B. I get the per unit prices, I get the corresponding revenues from each of those products, I get the total revenue. Now, notice there is also a total cost that is given to us. The total cost is 10 times QA, 10 times QA plus 20 times QB plus 1000. So, the total cost is also given to me. This is the total cost of producing these units. So, once I have the total revenue and total cost, I can very easily get the profit as the total revenue minus the total cost, total revenue minus the total cost, which is 267,900 rupees. 2,67,900 rupees is the profit of the firm when it is currently producing 1000 units of good A and 5100 units of good B. Now comes the critical part. How do I do a marginal analysis? So, let me go back here and make a few comments. So, we started with QA equal to 1000, right. So, I have QA equals 1000 and QB equals 5100, right. Now, when I had only one good, the marginal analysis is just obvious in the sense that I can either increase one more unit of the good. But when I have two goods A and B, to do a marginal analysis, what I need to do is I need to take that one extra step. I need to increase the quantity of good A to 1001, and when I do that, I need to keep the quantity of good B the same. The reason I want to do that is because if I increase both the quantities of A and B by 1 unit, then my revenue will change, cost will change, profit will change, but I will not be able to tell you how much of the change in profit is exclusively due to a 1 unit change in good A and how much of the change in profit is exclusively due to a 1 unit change in good B. So, for my marginal analysis with respect to good A to make sense, I need to change the quantity of good A by 1 unit, keeping the quantity of good B the same. So, this is the marginal analysis with respect to good A. With respect to good A. So, only change A and keep B constant, right, because that is the only way. So, because B is constant, now I can tell you that any change would have been exclusively due to a change in good A, and I can then quantify what the marginal revenue from good A is. Okay. Similarly, which is what we are going to be doing first. Similarly, so this is a marginal analysis with A. Now, if I want to do a marginal with respect to B, right. So, if I want to do a marginal analysis with respect to B, what I need to do is we will start at our original levels, right. We will start at our original levels, and notice now I will keep QA constant, right. I will not change A because my interest is to find out the impact of a unit change in the quantity of good B. So, what I will do is I will change the quantity of good B to 5101 and the quantity of good A will be the same as 1000. This will give me a marginal analysis with respect to good B, which is MRB, and here I only change B, keep A constant, right. So, my larger point then is instead of 2 goods, if you had 100 goods, right, and you want, so let us say good 1, good 2, good 3 dot dot good 100, and you want to do a marginal analysis with respect to good 3, let us say, then you should only change the quantity of good 3 by 1 unit and keep the quantity of good 1, good 2, good 4 dot dot all the way till good 100 to be the same. So, So, the essence is that you want to understand what is the marginal revenue from good A, you just change the quantity of good A by 1 unit, keep everything else the same. If you want to find out marginal revenue from good B, you change the quantity of good B by 1 unit, keep everything else the same. Okay. So, with this in mind, let me go back to my Excel sheet, right. So, I want to do a marginal with respect to good A. So, what I want to do is, I will write it as QA1 to denote that I am changing the quantity of good A by 1 unit. So, I am going to say this is equal to the old quantity plus 1, okay. And I am going to keep the quantity of good B the same as 5100, right. So, this is one more A, right, one more unit of good A. So, this is what I am interested in doing. I am going to keep the quantity of good B the same. So, I am not changing the quantity of good B, right. So, I will say same QB, same B, okay. So, same B. Now, let us find out what is happening. Now, notice that the price, because I have changed the quantity of good A by 1 unit and the inverse demand functions depend on QA and QB, the per unit prices are going to change, right. Now, intuitively I should expect the per unit price of good A to go down, right, because PA equals 90 minus QA by 100 minus QB by 300. I have increased A by 1 unit. So, I should expect the per unit price to decrease. So, let us find out the new per unit price. So, I will call this to be PA1. Okay. So, the new per unit price is going to be 90 minus the quantity of good A divided by 100 minus the quantity of good B, which continues to be 5100 divided by 300. And as expected, notice that my per unit price has gone down by a very tiny amount, right, but still it has gone down, okay. Similarly, the new per unit price of good B, right, the new per unit price of good B, I am going to write it as PB prime to indicate that here the quantity of good A has changed by 1 unit, right, or even better notation would be the per unit price of good B when A changes by 1 unit, right. So, PBA1 will denote the per unit price of good B when the quantity of A has increased by 1 unit. Now, notice the inverse demand function of good B depends not just on QB, it also depends on QA. So, even though I have kept QB constant at 5100, the fact that QA has increased by 1 will imply that to maintain the equality of the inverse demand function, the PB must fall. So, I should get a price PB which is going to be lower than 62.33. So, let us check. So, that is going to be 120 minus QA divided by 150 minus QB divided by 100. And notice it is a very tiny drop, 62.3267, and here it was 62.33, right. So, nevertheless, what I want you to sort of notice here is that an impact of a change in the quantity of good A is going to lead to a change in not just the per unit price of good A, but also the price of good B. So, now let us identify the new total revenue with respect to good A, only from good A, which we know is the per unit price times the number of units that I am selling, that is in rupees term. The total revenue from good B when A changes by 1 unit is going to be the per unit price of good B times the quantity of good B, because that does not change. So, that is going to be 317,866. Notice that the total revenue now from B has decreased. That should not be surprising, because I am selling the same quantity of good B, 5100 units, but now the per unit price of good B has decreased. 62.32 is less than 62.33. So, the revenue that I get from good B has gone down. What about the total revenue when A changed by 1 unit? So, total revenue when A changed by 1 unit is going to be equal to the sum of the revenue from good A plus the revenue from good B. This is my total revenue, okay. And what about the total cost, the new total cost? will just call this as TR new when A changes by 1 unit, and this is the total cost when A changes by 1 unit. Okay. So, the total cost is again 10 times QA, 10 times QA, which is 1001, plus 20 times QB, which is 5100, plus 1000, and you will notice that has increased by 10. That also should not be surprising, because the quantity of good B is the same. So, the cost of producing good B is the same, the fixed cost of 1000 is also the same, and the number of units of A has increased by 1 unit, right, and you have a factor 10 attached to it. So, 10 times that extra unit, okay, is 10 rupees, and the new profit when I produce one more unit of good A is essentially the total revenue minus the total cost, and you would notice that the total profit also has changed, right. Now, simply by looking at these numbers, by this simple arithmetical exercise, what I get is that my profit has actually increased. So, that tells me that taking this step is actually a good thing, right. Increasing A by one more unit is actually a good thing. But what I want to do is I want to write down the marginal revenue terms. So, let us first identify, I claim that the marginal revenue is an impact of two effects. One is a direct effect, right. So, the direct effect. What is the direct effect? Well, because one more unit of good A has changed, one more unit of good A was produced, the price per unit of good A changed, that altered the revenue from good A alone, which is 63,053, right. So, the direct effect essentially, which contributes to a change in revenue, right. So, the change in revenue is the new revenue from good A minus the previous revenue from good A, which is 52.99. So, essentially what I mean here is that an increase in one more unit. So, let me see if I can make a note here. So, an increase in A in quantity of good A by 1 unit is going to lead to a direct effect. The direct effect is exclusively due to change in revenue from good A alone, right, only due to a change in good A. Then, so that in this case turns out to be equal to rupees 52.99 per unit. That is essentially the new revenue from good A minus the previous revenue from good A. What is not clear here is that in addition to the direct effect, there is also going to be an indirect effect. The reason there is an indirect effect is the two inverse demand functions are interrelated, right. The inverse demand function of good B not only depends on the quantity of good B, it also depends on the number of units of good A that the firm is producing and selling. And because the revenue from B changed when you increased A by one more unit, that is going to lead to a change in revenue, which is going to come from the B component of the good. So, that is going to be equal to, and notice the revenue from B has decreased, which is the new total revenue from B minus the previous total revenue, and notice this is a negative number, right. So, this is minus 34. The sum of these two effects is going to give me my marginal revenue from good A, right. So, the marginal revenue from good A is not 52.99. So, let me make a note here. So, the indirect effect is due to the revenue change from good B when QA increased by 1, increased by plus 1. And notice when QA increased by plus 1, the revenue from B was less than the previous revenue, which means that the indirect effect is going to be negative here in this example, right. So, because I produced one more unit of good A, that caused PB to decrease, therefore, the revenue from good B decreased, and that is causing the indirect effect to be negative. Now, the marginal revenue from good A is essentially the sum of both the direct effect and the indirect effect, which is the sum of the direct effect and the indirect effect, which turns out to be equal to 18.99, right. So, the marginal revenue from good A is not 52.99, that is only part of it. The marginal revenue from good A is the change in total revenue resulting from a unit change in the quantity of good A. So, I had a unit change in the quantity of good A that led to a direct effect, which is telling me what is the change in revenue from good A alone. Then there is an indirect effect which is telling me what is the change in revenue from good B. The sum of these two effects is telling me what the marginal revenue from A is. I can also find out what the marginal cost of good A is. Now, the marginal cost of good A is essentially the total cost, the new total cost minus the previous total cost, and if you look at the expression for total cost, you will notice that the marginal cost from good A is going to be equal to 10, which then tells you the marginal profit. So, let me write it as marginal profit, M profit from good A, right. Marginal profit from good A is essentially the marginal revenue from good A minus the marginal cost, and this is a positive term. And if you notice, in fact, if I expand this a little, you will notice that this is essentially 8.99, right. So, 26 point, so if I do the arithmetic here, the new profit minus my previous profit is essentially 8.99, which is exactly what you have here, right. So, the whole point of this exercise is to tell you that when I change the quantity of good A by 1 unit, keeping the quantity of good B the same, my profit increased by 8.99. Is that a good thing? Of course, yes, because if I keep A at 1000, if I keep B at 5100 and increase A by 1 unit, that allows my marginal profit to increase by 8.99, and it allows me to move to a higher point on the profit hill. So, an increase, so the direct effect, so the marginal revenue from good A is the change in total revenue resulting from a unit change in the quantity of good A, keeping QB fixed, which is what we did, right. And the marginal revenue here is the sum of the two effects, right. It is the sum of this marginal revenue was obtained by adding the direct effect and the indirect effect. In this example, the direct effect was positive, the indirect effect was negative, right. So, when you aggregate the two effects, we got the marginal revenue as rupees 18.99 per unit. And because the marginal revenue and the marginal cost of good A was rupees 10 per unit, and because the marginal revenue, right, because the marginal revenue was greater than the marginal cost, what did we want? We wanted to take that step, we wanted the QA to increase, right, because by producing one more unit of good A, I was able to increase my profit by some amount. So, profit increases when one more unit of good A is produced. Now, similarly, we can do an exercise for good B also, right. What happens when we produce one more unit of good B, keeping the quantity of good A constant. That's going to give me the marginal impact of good B. We will do that next. Thank you.